So we're balancing reactions using oxidation numbers, and we're going to follow the steps 1 to 4. So step 1 says assign oxidation numbers to all species. So +1, -2, -6, +5, -2, -4, +4, +1, +2, -2, +1, +2, -2, -8. So that means S has to be +6, -2, +2. So now we have to figure out how many electrons are gained and lost. So if you look at nitrogen, it had a +5 charge, and it finished with a +2 charge. So that means it gained 3 electrons. Then if we look at the lost, we'll take a look at sulfur. And it went from +4 to +6, so that means it lost 2 electrons. Now moving on to step 3, we have to find the lowest common multiple that 3 and 2 go into. So our LCM is going to be 6 because 3 and 2 both divide into 6. So this is how we figure out the coefficients. We times this by 2 to get 6 electrons. So that means a 2 goes in front of that species. We times this by 3 to get 6 electrons. And that means a 3 goes in front of there. So now we have to balance the equation just like we would normally. Okay, so we have 2 nitrogen on the left-hand side. We're going to put a 2 over here to balance our nitrogen. I have 3 sulfur on the left-hand side, so I'm going to put a 3 over here to balance our sulfur. So now we're going to look at our hydrogens and our oxygens. So if I look on the left-hand side, I have 2 hydrogen and HNO3 plus 2 hydrogen and H2O for a total of 4. On the right-hand side, I have 3 times 2 hydrogen, which is 6. So automatically I know I need 2 more hydrogen. So I'm going to put a 2 in front of here. So now my hydrogens are balanced and I have to look at my oxygens. So HNO3 has 6 oxygen because there's a 2 in front. SO2 has 6 oxygen because there's a 3 in front. And then another 2 from H2O. So we're looking at 14 oxygen on the left-hand side. And if you take a look on the right-hand side, 3 times 4 is 12 for oxygen and H2SO4. And 2 times 1 is 2 for a total of 14 on the right-hand side. A little tip, if you do your hydrogens second last and leave your oxygens to the end, they often balance themselves before you have to do anything. So now we're going to look at the first example in your notes on the next slide. So our first step is we have to get the oxidation numbers set up. So +1, +3, -3, this will be a 0, -2, -4, +4, +1, +2, -2. So it's quite obvious we'll use nitrogen. It went from -3 to +4, which is a loss of 7 electrons. And then you might not be sure which one to use between hydrogen and oxygen. Well, if you look at the hydrogen, they both are +1 on both sides, so there's no change, so you can't use those. We always look at the first number, not the top number. So we're going to use oxygen, and it went from 0 to -2, so it gained 2 electrons. Now, because of this 2 right here, we need to times this by 2 before we find our LCM for a total of 4 electrons gained. And if you remember to do that, it'll make your balancing so much easier. So in this case, the LCM is 28. So I times this by 4 to get 28 electrons. So that means a 4 goes here. I times this by 7 to get 28 electrons. And a 7 goes there. So I got to balance my nitrogens first. I have 4 on the left. I'll put a 4 here to balance those. I also seem to have 12 hydrogen on the left, which means I need to put a 6 there. So let's count the oxygen. 7 times 2 on the left-hand side for oxygen gives me 14. And if I look at the right-hand side, I have 4 times 2 is 8, plus 6 is 14, so we're balanced. Here is example number 2 from our notes. So again, the first thing we're going to do is find the oxidation numbers. So -2, -6, so this is going to be +5. This is plus 1, plus 22, minus 2, minus 22, so this is just 0. This is minus 1, minus 2, minus 4, so that's plus 4. And then we have plus 1, plus 2, minus 2. So obviously we're going to use Cl. It went from a plus 5 to a minus 1, so that's a gain of 6 electrons. And then carbon went from 0 to plus 4, so it lost 4 electrons. But remember, carbon has a subscript, just like we saw in the last example. So we have to times it by 12 before we do anything with an LCM. Because 1 carbon lost 4 electrons, but 12 carbons lost 48 electrons. So that makes our LCM equal to 48. So I have to times this by 8 to get 48 electrons, which means an 8 goes here. Now this one is already at 48, so I don't have to do anything to it. You just leave it. So now it's a balancing game. So I have 8 chlorine there, I need an 8 there. I have 12 carbon, I need a 12 there. I have 22 hydrogen, so I need 11 there. And let's see if our oxygens work. So in ClO3, we have 24 oxygens. In C12H2O11, we have 11 oxygens, so that gives us a total of 35. Just label it as oxygen. On this side, I have 12 times 2 is 24 oxygen, plus 11 is 35, so we are balanced. So first step, find your oxidation numbers. So plus 1, plus 2, minus 2, minus 14. So that means CR2 is plus 12. So if I'm looking at 1 CR, it's plus 6. Because 12 divided by the coefficient or the subscript of 2 gives you 6. Plus 1, plus 2, minus 2, this is 0. Minus 2, minus 4, that's plus 4. Plus 1, minus 2. And then minus 2, minus 6, plus 6, but we have a subscript of 2, so 1 CR is plus 3. So obviously the CR charge was plus 6 and it goes to plus 3. Remember, we're using our bottom numbers, not the top ones. So what happened here? Well, we gained 3 electrons. But what do you notice about the CR? Well, we have this subscript, so we times it by 2 for a total of 6 electrons gained. Then we're going to look at the sulfur, and it lost 4 electrons. So what would be our LCM with 6 and 4? Well, the easiest one to use would be 12. So 6 times 2 gets me 12. I'm going to switch colors, so I'm going to put a 2 in front of here. 4 times 3 gets me 12 electrons. So I'm going to put a 3 in front of there. Well, I have 2 times 2 potassium for 4, so I need a 4 there. I need a 2 in front of my CR2. My S needs a 3 in front of it. And now let's look at the hydrogen. On the right-hand side, we have 4 times 1, so 4 hydrogen. So I need a 2 there, and let's hope the oxygen balanced. I have 2 times 7 is 14 plus 2, so 16 on this side. And then I have 3 times 2 with SO2, so that's 6. Plus 4 with KOH, plus 6 for a total of 16 on that side. So we're balanced. For our last example, we're going to do the exact same steps. Minus 2 minus 6, plus 6 plus 3. Minus 2 plus 2, 0. Minus 2 minus 4. Oops, I didn't write that very nicely. Minus 2 minus 4. And then this is plus 4. So we look here. Iron went from plus 3 to 0. So obviously that gained 3 electrons. And we have a subscript, so we times it by 2 for a total of 6 electrons gained. Carbon went from plus 2 to plus 4, so it lost 2 electrons. So our LCM in this case is going to be 6. So for that, we don't have to do anything to the 6. We just leave it as it is. For the lose 2 electrons, we have to times it by 3 to get 6 electrons. So we're going to put a 3 here, which means I need to put a 3 there. I have 2 iron on the left side, so I need to put a 2 there. And then let's hope our oxygens are balanced. So I have on the left side 3 oxygen here. And I have 3 oxygen and CO for a total of 6. And I have 6 on the other side. So we're balanced. Now, when you're doing your worksheet, if you want to snap me a couple pictures to check your work before you hand it in, feel free to do so. Make sure you understand this topic because we're building on it for our next lesson. Good luck and talk to you soon.